All right, number 7. This is our stoichiometry unit, extra practice problems, number 7. This one's pretty straightforward, I think, for most of you, but I'm going to go ahead and make the video just in case somebody still has a question. So empirical formulas mean that it is, how do I say this most succinctly? If you look at the subscripts on everything in your formula, if it has a common denominator where you can reduce those numbers, remember back in arithmetic really, or algebra, when you were talking about these things, pre-algebra probably, you might say, all right, well, if I have the numbers 6, 12, and 18, do they have a common denominator? And in this case, it would be 6, right? So you would say, all right, well, 6 is 6 times 1, and 12 is 6 times 2, and 18 is 6 times 3. So if I were to divide each of these by their common denominator, we'd be left with 1, 2, and 3. So what we're going to do is we're going to look at all of the subscripts on each of these and determine, are they as simple as they can be? That's what the empirical formula is. Now, I would like to remind everybody, caution everyone, that something, let's, say water. Water is H2O. You guys all know that water is H2O. You knew that before you started chemistry, probably. Okay? If water is a super unique, wonderful substance without which we would not have life on this planet. And if I were to say that I have H4O2, H4O2 is a completely different molecule. So H4O2 is not the same thing as H2O in real life. But for purpose of saying what's the empirical formula, what's the simplest formula for this, it would be H2O. Okay, so don't confuse that the empirical formula is the same. It's not. We're just trying to, like for math reasons, trying to figure all that out. All right, so looking at this, our subscripts here on SO3 are 1 and 3, and it really can't get any simpler than that. So our directions say to circle all of the empirical formulas. This one's as simple as she gets for these two. All right, looking at B, we've got K2, S2O3. There's no common denominators here. So if this had been O6, we might have been able to simplify it, but it's not. All right, so this one is also an empirical formula. These two over here, they are a different story, however. So if we're looking at this, I'm just going to cross out that little scribbling I did before. We've got C6, H12, O6. Oh yeah, these have a common denominator, it's 6. So if we were, it didn't ask us to write what the empirical formula is, but if we did, and we divided each of these subscripts by 6, we would have C, H2, O. All right, that would have been the empirical formula. The question asks, circle the empirical formulas. This is not, so we're not going to be circling this. All right, feel like you know where we're going here, but for P2H4, sure, they do have a common denominator, and it's 2. So if we were to divide 2 by 2, you'd get 1. Divide 4 by 2, you'd get 2. So again, they did not ask us to do this, but the empirical formula for this would be PH2. Again, I'm just going to say one more time, PH2 is not the same as P2H4. They have different properties. So this is really, this reduction that we're doing here is just for the purpose of saying an empirical formula versus one that is not. So that's it. That's all there is to this one.